Hello everyone, here is a series of 7 videos that presents the main ideas of the paper entitled Open Challenges for Machine Learning-Based Early Decision-Making Research. This paper has been published in the December issue of the CKDD Explorations Journal. Here are all the co-authors, and we have set up a GitHub with the goal of collecting papers, videos, tutorials, libraries, which address these new fields of research. Here are the titles of the 7 videos, and we start without further delay with the first one, which is entitled While Early Classification of Time Series is a Limited Problem. This first slide presents the successive steps of time series early classification through an application example, which consists in predicting as soon as possible if a user is malicious or not. The input of the system is a time series that is observed over time. In our example, this series could represent the number of network packets sent by this user over time. At each time step, the partially observed series is completed by a newly received measurement. In the second step, a collection of time-indexed classifiers is used to estimate the probabilities of each class at any time. Then, a trigger model must choose either to launch the decision or to wait for an additional measurement. The main issue in early classification is to achieve a good compromise between earliness and quality of decisions, and the goal is to optimize the timing of the decision. On the one hand, if the decision is made too early, there is a strong risk that the decision will be unreliable, that is, it will be wrong very frequently. On the other hand, a decision that is made too late represents a significant cost. In our example, the hacker will have enough time to do damages in terms of security if he is detected late. Finally, there is an optimal moment to trigger a decision, and the objective is double, that is, to make a reliable decision as soon as possible. The main issue of early classification is therefore to optimize the decision moment based on the partially observed time series. In practice, data scientists frequently use the following heuristic to answer this question. In this case, the triggering model is very simple and consists of a decision threshold. A decision is then triggered as soon as the estimated probability of the predicted class exceeds a certain threshold. To do this, the classifier must be calibrated beforehand. This heuristic is very common, but is this heuristic really effective? Is it possible to do better? Well, in the case of early classification, the answer is yes, and much better. Here are 2 important references related to early classification. The first paper proposed an approach called stopping rule, which is better than the threshold-based heuristic. And the second paper presents the state-of-the-art approach called economy. The second approach is the best one, thanks to a very important property, which is a non-myopy property, and that we will study later in the video number 3. This slide presents the game rules of early classification of time series. First, the training set consists of series which are all of the same length. This size is denoted by capital T and also represents the maximum decision horizon. It is the last moment to trigger the decision. The labels of each training example are associated with the entire time periods over which the time series are defined. When using the model, the input time series is observed progressively. The goal is to optimize the moment of triggering the decision. In the ideal case, this decision should be both correct and early as possible. This decision is final, which means that once it is made, it cannot be changed. Here is the ID card of early classification of time series, showing the limitation of this problem. Indeed, the learning task is necessarily a classification problem. The input data is necessarily a time series. The decision period is fixed beforehand and corresponds to the length of the time series. For each input time series, the decision is unique and it is associated with the entire time period over which the series is defined. Finally, the decisions made cannot be changed. They are final decisions. Eventually, these specifics could be changed. Thus, early classifications of time series is a specific case of a more general problem, which we call machine learning-based early decision making. This general problem can be seen as extensions, targeting, for instance, to change the learning task, to consider any type of data collected over time, to revoke decisions when it is useful. In the following video, we will present the general problem of machine learning-based early decision making. Thank you very much.